All right, so welcome everyone to Sustainable Newton. Tonight we have our presentation is by Pam Knox, and Pam is an agricultural climatologist with the Georgia Extension Office, and she's done work in climate for the last 30 years. So I'm going to turn it straight over to Pam and let her get started so we have plenty of time with her.
All right. And since it's a small group, it's fine with me if you ask questions during the presentation, because if you have to wait till the end, you might forget what you were going to ask. Or it might be that it depends on something that you're seeing on the screen. So I'm just going to go ahead and start. And like I said, feel free to stop me and ask questions. I could go back if I need to, and so on. In addition to being an agricultural climatologist, I'm also the director of the University of Georgia Weather Network. I'm not really using any information from that today, but if you want to know at the end, you can certainly ask me about that as well. So let me go ahead and start. What I'm going to try to cover in the next 30 minutes or so is how we describe climate and how it's changed in the past. And then we want to talk about how we expect it to change in the future. I know you guys are a sustainable group, but we're going to talk a little bit about resiliency, which I think is really related to that, and how to talk about resilience to your audience. So we'll try to cover a little bit of that as well. First of all, when you talk about, oops, don't want to go there already. When you talk about what is climate, there's a lot of different ways that you can define climate. If you ask most anybody what climate is, they might say it's the average weather. And that's a good starting point, but that's certainly not the end of it all. Climate is described not only by averages, but also things like extremes. How often do we get a really high temperature, record setting, or low? What the ranges are. We have a daily range of temperatures. We have an annual range of temperatures, and we have the range of temperatures overall. We have cycles. There's regular cycle, the winter summer cycle is a very regular cycle. There's longer cycles as well, going all the way up to 100,000-year cycle that's caused by how the Earth orbits around the sun. I'm not going to really talk too much about that, but that is something that's there. And in addition to all these cycles, there's also long-term trends, and we'll talk a little bit about those. Now, when you're describing climate, you can either describe it as what's happening at one particular point in one particular point in space, so a city or a county or something like that, or you can talk about it in terms of how things are changing over an area. So on the two graphs I have here, the top one shows the Georgia annual average temperature from 1895 on the left-hand side to 2023 on the right-hand side. That's the last full year that we have. You see there's lots of interesting things in that graph, and I'll talk about that a little bit more in just a minute. And then on the bottom is a map that shows how the temperatures over the last, for the first 3 months of 2024 have varied compared to the long-term average. You can see there, the northern part of the United States was by far the warmest. I grew up in Grand Rapids, Michigan, and went to grad school in Wisconsin, so that's my neck of the woods. And it was very warm there, probably mostly in part due to the El Nino that we had this past winter, and I'll talk a little bit about El Ninos as well. And so, but you can see that it's not the same everywhere. So if you have relatives in different parts of the country, their experience could be quite different than yours. And so we were talking about that a little bit before the talk here started. We could also talk about it in terms of what's happening every day at your place. This is what we call a thermograph. A thermograph shows what's happening across the course of a year. This is a thermograph for 2023 for Monticello, Georgia, which is the closest good record I could find to Newton County for 2023. And there's a lot of different things going on here. You can see there's the green band. That's the that's the daily average temperature, high and low, for each day of the year. It's pretty smooth. You can see the seasonal cycle there. The reds are the record maximum temperatures for each date of the year, and the blues the record minimum temperatures. And then superimposed on top of that are the gray lines are what actually happened each day in 2023. There's lots of interesting things there. You can see that there were some time periods where there were pretty big swings. In 2023, of course, we had a pretty warm winter. And then in mid-March, we had 2 cold spells. You see temperatures got down to 25 on several different nights in Monticello, and that was what really eliminated peaches from last year's production, because it got so cold for so long that the peaches just could not, the flowers all froze and they did not have a peach crop
Pam,
left.
you got my blueberries.
And the blueberries too, that's right. And so that was a real problem for a lot of producers. The commercial blueberries in Georgia are mostly in southeast Georgia, so they were in better shape than the local plots were. But I know most people in North Georgia just lost their blueberries as well. So I'm not surprised that you had trouble with that. You can see if you look at the summer was actually quite seasonal, because those daily high and lows were very close to the long-term averages. And then when we moved into fall, we went through some very big swings in temperature. And those things, that's pretty typical for fall. We have a front that comes through, brings cold air behind it. Ahead of it, it might be warmer. And so more frequent to see these swings in temperature in the spring and in the fall than it is in the summer. And so that's just another way of looking at the climate. So you can see how each day compares to the long-term averages. And I got this from the Midwest Regional Climate Center at Purdue. There's most of my graphs, you'll see that there's a link on the bottom in case you want to go and look at it for another part of the country or the state. Some of the records are longer than others. So let me spend just a little bit more time now talking about the Georgia average temperature. This is the average annual temperature for the state as a whole. So it's a combination of about maybe 100 stations around the state. So it's not necessarily dominated by urban stations like Atlanta, but most of the stations are actually out in the country. So they're not really feeling much influence of urban heat islands. And so you can see there's a lot of interesting things there. When I talk to farmers, they all look and say, well, whatever happened last year, it's not going to happen this year, because there's a lot of swings back and forth from one year to the next. There's also some longer term trends on here. You can see from 1895 to about 1925, there's a slow increase in temperature. And after that time, from about 1925 to about 1965 or 1970, temperatures were decreasing over time. And then since then, temperatures have been going up much more rapidly, but there's still this year-to-year variation. And so, if you look at this, you could say, well, what's going on? What's causing some of those different things? And climatologists spend a lot of time looking at that. But really, the trend that you see depends on how old you are and when you lived. So I just drew some different lines on here to show different trends depending on where you are. If you look for the record as a whole, that's kind of that salmon pink line that's rising slowly over the longer time period. The blue line is a period when temperatures were going down over time. We think there's at least a couple reasons for that. One is that land use was changing in Georgia from mostly bare grounds, a lot of cotton crops and so on. A lot of that moved out to California. And so instead we planted a lot of pine trees. And pine trees keep things cooler than a bare dirt cotton crop does. So that was probably part of it. But in the last couple of years, scientists have shown that probably one of the biggest influences of that cooling were because that the atmosphere got a lot dirtier. That's because they were burning a lot of coal in the Midwest. The coal puts out this black soot, and that keeps the sunlight from getting all the way down to the surface. And in 1970, you might remember, that was when the Clean Air Act was put into effect. Thank you, Richard Nixon. And that cleaned up the atmosphere, and all of a sudden temperatures started rising. And so, that was kind of a human caused climate change because of land use changes and because of how we were putting all this black soot into the atmosphere, even at the same time that we're putting in carbon dioxide. But since that time, temperatures have gone up quite a bit. And so The average age of a farmer, I think, is about 60 or so years old. So, and for most of us, I'm 66. We've been in that period of where the green line is, where things have been going up over time, and you can definitely see that. Varies by season, it varies by location. We'll look at that a little bit more. I put the red line on here because for a long time, there were some TV or radio hosts that were saying, "Oh, well, the temperature is not changing. We hit this maximum, the temperature is not changing." And that was probably true for about 10 or 15 years, but all of a sudden, boom, the temperatures went way up, and so that really was not true anymore. Whenever you see a graph that has a trend line on it, you have to look and see what's the beginning point and what's the ending point, because that's going to affect what kind of trend you see. And if you're really old, you're going to experience things a little bit differently than if you're a younger person. One of the things that those changes in temperature has done is it's affected the USD plant hardiness map. I don't know if any of you are gardeners, but I assume you probably are. The plant hardiness zone is based on the lowest temperature you expect anytime during the year. Of course, usually that happens in the winter. And as the temperatures have warmed up, the zones have also changed. So in Newton County, it's changed from 8A to 8B, which means it's getting warmer. And you can see this is a map that shows how much it's changed from the previous edition, which was from 2012 to 2023. It's most places in the United States, especially in the eastern half of the United States, have gone up by half a category. So that means you can grow different plants. You can grow more tropical plants in your area than you used to be able to do. And you can actually go to this plant hardiness website and you can zoom into your own location and see exactly what changes have happened there. There you see there's a few places in the western US that actually have gotten colder. That's just mostly because they have better data than they used to. So they had more information and they revised the maps to take advantage of that extra data. But because temperatures are going up, that we're seeing the plant hardiness zones change, and also, where other kind of native species grow, and also where birds will spend their winters and so on. If you look at other parts of the country, temperature has also changed, but it hasn't changed the same everywhere. The annual temperature, you can see a lot of the U.S. has gotten warmer more quickly than we have here in the Southeast. And that's because we had that period of cooling off from 25 to about 70 or so, which other parts of the country did not have. And so many places in the United States have been seeing a steady increase in temperatures, including up in Wisconsin and Michigan. And other parts have seen much slower, especially if you look at that long time period, changes. Now, if you just look at the last 60 years, the temperature trends across the whole US are pretty similar. So that's more of an artifact of that cooling off period than anything else. You see, winter's warming up faster than summer is. One reason for that is because there's less snow than there used to be. So we get less reflection from of sunlight off of the snow back to space, which keep things relatively cool. But also summer in that area that's in blue on the bottom right-hand map is where there's a lot of irrigation for crops and for agriculture. And you put a lot of water into the atmosphere, you get more clouds. It's harder to get things really warm. And so the summer temperatures are being affected by irrigation in a lot of that cropland. You see, there's not nearly as much of that in the western part of the United States because they don't do much irrigation there. If we look at how precipitation has changed over time, the story's a little bit different. This is the Georgia annual average precipitation, again, from 1895 on the left to this is 2022. I forgot to update this one, I guess. But you can see there's no trend in the annual average precipitation over Georgia over the last 125 years. There's still a variation from year to year, and that causes problems for things like agriculture, for water supplies, for how your lawns do, whether or not you have to add extra watering to your lawns and so on. But all those things are part of the cycle that goes back and forth. One thing you will notice if you look at the right-hand side of that is we have more multi-year periods of really dry conditions, and that's led to some of the droughts that we've had in the last 20 years or so. So if we look at precipitation across the United States, precipitation across the United States, U.S. as a whole has been getting wetter. That's because as temperatures get warm, there's a lot more evaporation and water vapor from the oceans, and that comes on shore and falls as rain. And so a lot of places in the United States are getting wetter than usual. And seasons vary. Here in the Southeast, the fall is really the season that's getting um, more wet the most quickly. Other seasons are actually drying out a little bit. Um, and so a lot of there's a lot more movement of this moist air into northern parts of the United States. In fact, in places like North Dakota, they used to only be able to grow wheat because they didn't have enough moisture to grow corn, but now there's enough rainfall that they can grow corn up there, which is a more lucrative crop for them. And so they've switched from a wheat-based agricultural economy to one that's much more corn, especially in the eastern half of North Dakota and in Minnesota. And so those things are changing over time. Seasonality is important because when you're growing something, you got to know, is there going to be rain at the beginning of the year to get the seeds germinated? And at the end of the year, you don't want it too wet because then it's harder to harvest because you can't get that heavy equipment into the fields. But all those things, fall into the different patterns. So annual doesn't tell you everything because you need to know when is the rain falling as well as that you're getting 50 inches or so a year. Mentioned drought. Drought is just one kind of extreme climate. And, drought communities can usually adapt to gradual changes much more easily than they can to changes in extreme weather. Extreme weather could include things like tornadoes, hurricanes, ice storms, heat waves, flash flooding, probably a few other things as well in there. And extreme climate includes things like both droughts and floods. We expect both to go up in the future because we're just having this really ramped up or amplified water cycle. So when it's wet, it's really wet, and when it's dry, it's really dry. This bottom graph here shows the Georgia percent area in drought. Starts in 2000, which is when this particular map was first produced, and goes pretty much through the present. You can see when I came to Georgia in 2001, we were in a drought. It was a pretty bad drought. It started in 1998 and then lasted all the way to 2022. Caused a lot of problems, and the government created a drought plan at that time, which they put into effect when the next drought came in 2007. You might remember that drought. It was so bad in Athens that they had monitors in the bathrooms at the football games to make sure people didn't flush too much because our reservoir was down by 14 feet and people were worried about Atlanta running out of water. That was a very hot drought, mostly in North Georgia. The next drought after that, 2021 or 2011 to 2013, was more in the central and southern parts of the state. Didn't get nearly as much attention because it wasn't in the Atlanta market. But for many parts of the state, it was longer and more severe than it was for us here in North Georgia. Since that time, we haven't had any really big, long droughts. It's only a matter of time before it happens. We have had some shorter droughts, the 2016 to 2017. That was the one that had the fires in Gatlinburg, Tennessee. You had a lot of smoke here. I remember walking out of my office just smelling what smelled like a campfire from all the smoke that was coming off of those fires up in the mountains. We've had a couple of the real short ones since then, but we haven't really had a long one. And so it'll be interesting to see. It kind of feels to me like we're overdue, but it's hard to talk about it that way because in climate, every year is unique, and you're not always able to predict it. If I had to guess, I would say we could see a drought later this summer. I think probably we're more likely next year because this coming winter is going to be a La Nina winter, and it's going to be relatively warm and dry. So we'll just see. The other thing about rainfall is that how it comes down is also important. When the rain falls as a thunderstorm or something like that, you might get 2 inches in a day. We consider that to be a heavy rain. Other days are relatively light, and you might only have you know, 1/10 of an inch or so. I have a rain gauge in my front yard because it's the only place that doesn't have trees. And if you have a garden, you might very well have one as well. But what we've seen is that we're getting more of these really heavy rain days, but there's also longer dry spells in between the rains. And so that is something that's of concern to farmers because the plants have to get usually at least 1 inch a week, maybe 1.5 inches when they're blooming. And so if we have really heavy rain, but the rain all runs off, it's not available soil moisture. And so, you know, the plants have to suffer through that longer dry spell. And so irrigation becomes more important. And it's also important for things like flooding in your city streets, because if you have these really heavy rains, the gutters just can't keep up. So you have more flooding and you have more accidents with that. Infrastructure just does not do well when you have heavier rain. Okay, well, let me switch now and talk a little bit about how we expect temperature to change in the future. The amount of warming that we're probably going to get depends a lot on how much additional greenhouse gases are emitted into the atmosphere. You know, as we burn fossil fuels, and emit methane and so on, that is all contributing to what the climate's going to be like in the middle and late in the century. So for our kids or for our grandkids, what we're seeing now is basically based on what was emitted 30 years ago. It takes a long time to work its way through the atmosphere. No matter what choices we make, the Arctic is going to get the warmest because of the loss of snow and ice. And so they're likely to see more warming temperatures, and we're seeing that now already. One of the things we also know is that the average temperature that the climate models produce for us is not very useful for things like predicting agriculture, because agriculture, you're not looking at the whole year, you're looking at the growing season, and you're usually looking at specific things like for fruit, maybe blueberries or peaches, you're looking at chill hours, how cold does it get for how long. For other things like corn, you're looking at, you know, how much heat do you accumulate over the growing season. So those are the kinds of things that the models don't do nearly as well with. But we know it's going to get warmer. We just don't know exactly how much because it depends on our actions now. And that is something, you know, it's hard enough to predict the weather, but it's much harder to predict human behavior. You know, especially if you've got little kids, you know that that's true, but even older kids often are not very predictable. How we expect precipitation to change in the future, we're already seeing it's getting wetter, and that is expected to continue. It's going to change by seasons. Probably the wettest will be in the winter because a lot more water will form as rain rather than snow in the northern latitudes. And so those areas will get a lot more rain than they would have the water equivalent in snow. So that's something that's going to see. The water supplies could be more variable or less available, in which case, especially if you see down in the summer, a lot of the United States is going to get drier. You know, there's going to be competition for water. You're going to have people wanting to irrigate for their crops. You're going to want to have people that want water for recreation in their lakes. You're going to want people that need to drink it. And so all of that's going to put more stress on the water delivery system. And if we do have the heavier rain, as we expect to continue, the infrastructure is going to flood more often because it's not really built to handle that heavier rain. So that's going to cause more problems for driving. It means that bridges are probably going to have to be replaced more frequently. There's going to be more local flooding and so on. So how do we expect extreme weather to change? There's been a lot of tornadoes this year. You probably noticed that. We don't really think that that has to do with climate change. That's more just variability. If you look at the long-term trends and the number of tornadoes over the United States, it's really, there's not big trends in that. The biggest trend is it's small tornadoes, and climatologists think that's probably because people have cell phones, and they, you know, when they think there's going to be a tornado, they go out and take pictures of it. So people are much more aware of those than they used to be. With the big ones, they've always been able to find because they make a big mess. The smaller ones are getting counted more often because people are watching them and taking pictures with their cell phones. So we do think that the number of tornadoes probably isn't going to change too much. We have noticed that there's a shift so that there's relatively fewer tornadoes occurring in the Oklahoma and Texas area, and more in the Mississippi and Alabama area. but still, there's still a lot more in the central part of the US than there are in the southeast. So that's not going to change overall. It's just the pattern, relative numbers is switching a little bit. Trend in hurricane numbers. So this is going to be a big hurricane year this year because the ocean is really warm. Temperatures, hurricane numbers, it's not really clear that we're getting more of them, but we do know that the ones that are occurring are moving slower, especially when they come on shore. If they move more slowly, they're dropping more rain. And you've seen some of that, like Hurricane Harvey down in Texas a few years ago, drop 60 inches, which is just amazing. I think the biggest number I've ever had in Athens is about 6 inches from one of the hurricanes, I think probably Ivan in 2004. But anyway, so the number of hurricanes is not clear if we're going to get more of them or if they're just going to get moving more slowly and dropping more rain. They could, if they're more slowly, they're probably going to increase in intensity as well, which means higher wind numbers. We do expect to see more floods and more droughts in the future due to this hyperactive water cycle. So that's something that people are going to have to deal with, both from a garden standpoint, water supply standpoint, all those things. In Georgia, there's not many places to even build more reservoirs. So how are we going to deal with more frequent floods? I don't know. That's a good question. We have to figure out ways to conserve water a little bit more than we do now. There's certainly going to be more heat waves. The heat waves are going to be made worse because humidity levels are high. You know, they say it's not the heat, it's the humidity, but it's really both. And so those are all things that are going to be more important, especially if you live in a city where temperatures are higher to begin with, and because of all the pavement that's there, and usually less wind as well. We do expect to see fewer gold outbreaks and ice storms, but they're going to still occur. It's just they're not going to occur as often, so communities are not going to really be prepared to deal with them. And so that's something that we have to think about. Okay, I want to spend just the last few minutes talking about how do we respond to all these changes that we're seeing. We talk about resilience a lot, and I use some of these slides in another talk where they asked me specifically to talk about resilience. How do we bounce back from any natural disaster or anything that's caused by these changes in the climate and in the weather? And you really have to think about what can we do to deal with changes in the water cycle, to deal with increased temperatures, to deal with how hurricanes come on shore. Didn't even talk about sea level change. That's certainly an issue if you live along the coast as well. So what can we do to respond to that? And if you want to create resilience, first of all, you have to figure out what are the problems we're going to have to deal with. And we're going to have to monitor those and figure out what are the likely ways that these things are going to occur. How are we going to know they're happening? What can we respond to ahead of time? What do we have to do when one of these events starts? We also need to talk to the people who are being most affected by it. We call those stakeholders. What needs do they have? What do they need to know? What do they, where do they need to get the information? And where do they get the resources, especially if they're poor, to be able to make these kind of adjustments? And so once we know that what's important to the different groups, then we can start to develop plans to respond to the changes, and we can identify people who might have special needs. For example, people that rely on power to run oxygen generators or something like that. So we need to figure out ways to make sure that they're also protected. And if we have more frequent power outages, which we could have if we have more strong hurricanes, or if we have more floods or something like that, that cuts into the power supply. And then you mitigate or you make changes now to prevent the worst things from happening, and then adapt where you can't mitigate to future climate. So there's all these different things that are going on in terms of building resilience, and being sustainable, of course, is all part of this. I just wanted to throw in a little bit here about agriculture because that's what I do. When you have climate variations, the things that affect for temperature, affect when things are planted. If the soil is warm earlier in the year, you can plant earlier in the year because most seeds germinate at specific soil temperatures. Corn usually about 50, maybe 55. Peanuts more like 65. So you plant things when the soil is warm enough so that the seed is not going to just sit there and rot. Frost damage, of course, is something that's a problem for agriculture, how fast the crops grow, when fruit trees or blueberry bushes start blooming. And then, of course, heat stress on animals, outdoor workers, and some crops, especially as you have more problems with humidity. For precipitation, you need to have water for the crops. It depends on what growth stage they are. Corn uses the most water when it's pollinating. So it's especially important to have rainfall during that time period. And if you don't have water, or if you have really hot temperatures, then you're more likely to get drought, and that's going to impact your ability to irrigate. It's going to impact your crop yields and so on. And then, of course, events like storms can damage or flood crops and fields, as well as damage infrastructure that might be needed for transportation of something like milk. If you've got a dairy and you milk the cows every day because cows won't wait. And you have to transport that milk. And if the road's washed out, then what are you going to do? You're going to probably have to dump the milk, which is a loss to the farmers. So in the future, we expect agriculture to change by increasing growing season length, increasing having warmer winters, which may or may not impact fruit production. For blueberries, there's different kinds of blueberry species that depend on different amounts of cold weather. And so I think the southern high bush grows farther south. They can take warmer winters. The rabbit eyes grow a little bit further north. They can take more cold over the winter. If you have more dry days, you got to worry about, will I have water to irrigate? Can I afford to irrigate? Some of those big irrigation systems are $100,000, and it's clearly out of the range of what smaller scale farmers can really afford to buy. So they got to figure out a way to get by on less water, either by putting in a different crop or pumping out of a farm pond or something like that. And more hot nights means more stress on livestock and workers. So all those things, and this is just agriculture. Every other aspect of society also has impacts that we have to consider. So when you're talking to other people about these things, you might see a range of different responses based on who you're talking to. This is the Six Americas figure from Yale Climate Change. And you can see that there's a certain number of people that are very alarmed about this. And quite another large amount that are concerned about it, but not necessarily alarmed. And then at the other end of the spectrum, there's the people that are dismissive and say, oh, well, the climate's not changing. That over time, that has been going down a little bit. I'll show you in just a minute. But you have to consider what your audience is when you're talking about it. If you're talking to people who are alarmed, you're going to get a different response than people who are dismissive. And so you need to think about that. At least I certainly do when I talk. This shows the pattern of changes over time. You can see the alarmed has been growing and concerned has been growing. Dismissive really hasn't changed that much. Some of the middle ones are decreasing a little bit more. So it's become sort of more bifurcated, so that there's either you're alarmed and concerned or you're dismissive, and then there's fewer people in the middle there. That I think every time we have an extreme event, that becomes a little bit more separated. And I think that will continue over time, but we're never going to get rid of people that are dismissive about it. So what kind of messages can you give? Talking about doomsday scenarios is probably not going to work for most people. And people will say, well, what's the point? So you don't want to talk that way. You want to talk about how can we be sustainable? How can we build a resilient society? Local action can be really important. So what you're doing is an important part of the process, because people will feel empowered to make changes that are going to help not only the local areas, but help the earth as a whole. You need to be able to elect leaders who are willing to take those to make those changes so that we can improve resilience and sustainability in the future. And we know that other countries are not necessarily acting the same way that the United States is, but we can provide leadership to become more resilient. In fact, in many cases, Europe is more sustainable than we are here in the United States, so we can learn from them as well. So some of the actions we can take now, and I'm sure you probably talked about this in your group, food waste is probably the single most big producer of greenhouse gases in the United States. About 40% of all the food is wasted. When you think about that, you're wasting water, you're wasting diesel fuel to run all that farm equipment, you're wasting human labor time, and you're taking a lot of fertility out of the soil that you have to put back in using fertilizers. So if you could reduce food waste, then that is one of the biggest things that most consumers can do. And that's can be done in the homes. It can also be done in factories and even on the farm fields. So, buy stuff that you know you're going to be able to use, and then try not to buy more than you need. And so that's really an important thing. Usually helps to eat less meat and more vegetables. I am probably not going to give up my meat, but I do try to eat less of it and mix it more with vegetables. Something that it's going to be a little bit different. Some people really are, they really want to do the maximum that they can, in which case they will eat vegetarian or even vegan. But even if you just cut down on meat, then I think you're really doing well, because meat production, and especially beef production, does produce a lot of greenhouse gases. And so you just need to be a little careful about how much you're buying, making sure that you don't waste any of it, and making nutritious choices, which is probably better for our health anyway. Another thing to do is to become more energy efficient. I drive a Prius now. Don't want to get rid of it yet, but I think my next car will probably be an electric car, because I do mostly local driving. That's one way to cut down on using fossil fuels and using more renewable energies. Georgia is a great place for solar. Not so good for wind, because we just don't have really strong winds here most of the year. And so solar is really what we're going to be good at in Georgia. And so that's something to keep in mind. If you're interested, you can go to Drawdown Georgia, look for it online. It's got a lot of other great ideas as well. And building resilience and becoming sustainable also can save money, because you're not wasting money on food you're not going to eat. You're not wasting money on driving cars that have poor gas mileage. So there's a lot of different things you can do that are going to be sustainable and are going to also be economically important. So all those things are really critical. So that's all I've got. And you're very quiet, 7:40. I know I don't think you have a meeting after this tonight, but I'm happy to spend a few minutes talking about any questions you might have or suggestions you have for things, or tell me a little bit about what you're doing to become more sustainable. I'd like to hear that as well. So there's my contact information, and since this is being recorded, you can get that from there, or you can talk to Nancy, and I'm sure she'll be happy to share that. So I'm going to stop sharing so you can see my face. All right. I don't know if we picked up any more people, but I'm happy.
Yes, we actually do have quite a few people. We have a total of 11 participants
Excellent.
tonight. So that's great. Pam, thanks so much. I think we're all, the information is
There's a
really
lot there.
It's a lot, but it's very
Yeah.
powerful.
Yeah.
And so I am going to ask if anyone has questions, if you want to put in the chat and I can monitor the chat, or since there are just 11 of us, we should be able to manage this just fine. If you can on your screen, raise your hand, and I'll try and keep up with it that way.
And if you don't have any questions, then maybe somebody can tell me about some of the initiatives that you guys are doing in Sustainable Newton.
First I want to know, what is Theodosia sitting under?
Can you hear me?
Yes.
Okay. I'm sitting on a luggage rack.
That's what
Okay. The parking lot outside in St. Simon's, and it's raining, so I hope it's not too loud.
Yeah,
Pam, I wanted to ask you about the gnat line. I have been really curious about that. It seems like this spring we have had so many gnats in our area, and I'm like, oh, that gnat line is moving. What have you heard?
Well, I mean, gnats are related to both the soils, it's more sandy soil in South Georgia, and also I think to rainfall. This has been an incredibly wet year. because we've been in an El Nino. I didn't really talk about this, but El Nino and La Nina is a oscillation over about a 3 to 5 year period that affects the climate of really the whole world, but certainly we see it in Georgia. When we're in one half of it, the El Nino half, like we were this past winter, it's really warm and dry in the northern part of the US, and it's wet and cool in the southern part of the US. And we have definitely seen that this year. It's been very wet. And I think that's contributing to the gnat problem this year.
Yeah.
Next year, we're going to be in the opposite phase. So here it's going to be warm and dry probably in the winter. So maybe a few less gnats next year.
And Pam, what adaptations have you seen farmers in Georgia making, whether the crops they grow or their
Yeah,
just
there's a
their
lot of different
practices, maybe?
adaptations farmers are using. One is the kind of crops that they grow. I mean, even if you're a peach farmer, there's peaches that take more cold weather and other peaches that take less cold weather, so they can switch varieties. And most farmers grow several kinds as a way of risk reduction. So even if one of them gets hit, another variety will do all right. They can switch to other kinds of crops. So you might grow peanuts instead of, because peanuts are usually more adapted to warm weather. Peanuts or cotton, maybe less corn. There's also a move here to grow new crops in Georgia. For example, they're growing Satsuma oranges in the southern part of the state. Those are the most cold hardy of all the citrus. It's a good way to do it here because they don't have the problem so far with citrus greening that they do in Florida. They're also growing things like olives. You know, I would never have thought they'd grow olives in Georgia, but they're growing that now. I just bought my first bottle of Georgia olive oil to see what it was like. It tastes pretty good.
It is good.
Yeah. So that's something that's growing. They're also looking at things like pomegranates. Some places in Florida even talked about doing things like vanilla. It's not quite warm enough in Georgia to do vanilla. You know, it's an orchid. And so- but there's a lot of things that they can do for that. And so they're also doing things like planting cover crops on the ground in the winter because that keeps the moisture in the soil, keeps the nutrients there, and it reduces erosion from some of those really heavy rains that we're having. So there's a lot of different things that farmers can do. They're a little slow to adapt to things like electric tractors, but they're coming and they're getting better. And so I think over time that's something that's going to become more acceptable. You know, everybody loves their John Deere, but things change over time, and
They're
as
pretty expensive, like you said.
I know they are. And so, you know, there's different management techniques you can use. There's different land use techniques you can use and different crops you can grow. And they're all different things that farmers are doing. Some people are also selling part of their farmland or using it to put in solar, which gets mixed reactions from the farmers because they don't like you to take productive agricultural land, you know, off of agriculture and onto solar. But solar is a good source of income for a lot of farmers. And so that's also part of the mix of, you know, what they're doing with their land.
So you did ask what we were doing
Yeah.
in Sustainable Newton. I think I shared with you before we went on the recording that we have several committees, and we do our committees based on the Drawdown Georgia framework.
Excellent. Yep.
So we're very familiar with that. We attend Ray Day every year so that we're really connecting with those other groups that are involved in Drawdown Georgia.
Yep.
We have these committees. One is our we have a communications committee that gets all this information out to everyone. We have an ethylene oxide committee, which I said Bill was monitoring ETO. We have an Inflation Reduction Act committee, and so we're looking at how we can move towards electrification. We have an events committee, so we try and attend every single event that's related to sustainability. A transportation committee that is looking at alternative forms of transportation, especially EVs.
Yep.
And then a waste diversion committee. And with that waste diversion,
So that's a food waste thing a lot. Well, plus other kinds of waste too.
Our landfill director, who is the current Georgia president of the Georgia chapter of SWANA is very passionate about the food waste because 70% of the landfill at our Newton County landfill is made up of food waste, and he would like to embrace composting, but it's slow because people are still in that mindset of recycling, and they still quite don't get the other sides of the triangle. So, we're working towards it, and change is slow and gradual, but we do have a lot of different ways in which we're.
Well, good for you. It sounds like you're really on the right path there, and I really appreciate talking to groups that are kind of ahead of the curve there. So you've already heard a lot of this information.
Well, but it sure is good to hear it again, because the more we hear it, the more it sinks in, and like I said, this is being recorded, so we will post this on our website. We really are very appreciative of you, and we'll share that information along with the presentation on our website. And so you might hear from a lot of us in the future.
That is perfectly fine. I'm glad to spend a little bit of time with you, and keep going. You're doing a great job.
Thanks so much, Pam. We appreciate it.
All right. Nice to talk to you all.
And